I'm not. Is she showing what it is? Being stingy.
I promise y'all was so tired too.
So what's the value of 25 minutes for the wood fire?
There. Let's go to it. I said the probability of Antonio.
Thank you. Thank you. Okay. So I hear the really good discussions. I hear and I see z-scores and graphs going all over the place. When we get to something you haven't already written down, start writing there. But I do want your attention and focus up here for a second because I want to talk about a couple of things. First off, again, draw your graphs, right, with the mean given and putting in the standard deviation, but show your z-scores because it's going to help once you calculate a z-score. Second, I do want you to pay attention to this because this was one of the #1 mistakes. Salita, Key Anthony, stop writing for a second. Colin, hold on. Zaria, hold on. This is a mistake that I saw on a whole lot of our homeworks. Anybody know why? And it wasn't just random. I should have titled it. Why did I draw wood-fired with wider out and shorter?
Because it has a bigger standard deviation. Bigger spread.
It has a larger standard deviation, so it is more spread out.
Oh, yeah, that's right.
The
Okay.
mean's also smaller.
Well, and see, that's the issue. That's what a lot of us talked about. Guys, how high it is does not have anything to do with the mean.
Nope.
Remember, the mean is a measure of center. The measure of center is left versus right. The larger mean would be further to the right. The smaller mean would be further to the left. So if I put both of these graphs on the same axis, this mean would be further to the left. It would just get messy if I put them on the same graph. The height and the width both tell you about the spread. I need you to hear me clearly on that. The height and the width tell you about the spread because if it gets taller, it's also going to get slimmer or skinnier. If it gets shorter, it's also going to get wider. The height and the width both tell us about spread. And this standard deviation was
25. Wait, no, 8.
8, okay. And this standard deviation was 3. And so because this has a higher standard deviation, it has more spread to it. Okay? Alright, so again, I want y'all to notice. It took me way longer to get to that first homework than I meant for it to, but I use your homeworks to give you feedback on what I saw us doing right and wrong. Homework is not one of those things to be played around with. It's so I can see what you're doing, but also come into tutoring and ask those questions. So I'm going to throw it to y'all to talk about number 2 for a second. Before you did any calculations, who did you think to go with for that pizza shop? Notice again, not when you've done the graphs and the calculations for number 3, just looking here with number 2, who would you have gone with in general?
I understand, Antonio.
You were thinking Antonio originally?
No, I was thinking wood fire
Why would you have thought wood-fired originally, Emma?
because the mean is 25 minutes, like the standard delivery time, and the standard deviation's in 3. So in my mind, I think it'd be a lot shorter of a wait.
So one thing to push on, what's standard deviation here?
8.
8, right? But you're 100% right that the mean average wait time is 25 minutes. So who are you going to go with? Personally, I'm probably going to go with wood-fired. It has a better mean, right? It takes less time on average. Okay? But what's the issue with wood-fired?
The standard deviation.
That standard deviation?
Way bigger.
Standard deviation is way bigger. So here's where we want to consider it depends on what your time limit is. Because when we look here, I'm going to come back to those graphs in a second. When we look here, what was the probability of getting the pizza from Antonio's within 35 minutes?
1.6 repeating.
Hold on one second. Probability within 35, I should be more clear with this. Probability of getting pizza from Antonio's within 35 minutes. Okay? Is, and Alicia, were you saying something?
1.6.
So the probability is 1.6. Okay? Anybody want to add on to that or push back on that probability? Say again. Oh, is that the z-score or is that the probability?
This is
That's
the
the
z-score.
Okay, so we need to be careful, right? I'm asking for a probability here, but the z-score, 1 tells you how many standard deviations above or below. Do I need that z-score? Heck yeah. Is that going to give me my probability?
Yes.
Yes, but be careful, because, and here's another thing to be a quick check. Probabilities have to be between what two numbers? 0 and 1. If it's never going to happen, probability is 0. If it's definitely going to happen, it's a 1. Probability is between 0 and 1. Okay, so we need to use that z-score to get our probability.
0.9452.
Is 0.9452. Anybody want to push back on that or ask a question about that? Destiny.
That's the area.
Okay, but I'm.
It's wood.
I'm
It's
not.
onions.
How you find it?
What time? 2.5.
0.9515. That's pretty close. What z-score did you go to?
1.6.
You went to 1.66. Hold on. What's another z-score that you could have used here on the table?
1.6 and then the 7.
You could have done 1.67, or what's going to be more accurate than the table when you have a repeating decimal? The calculator. So my bet, Destiny, is it depended on which z-score you use and whether you use the calculator. So who said the 9.9452? Madison?
No, this should be it.
What, did you use calculator or a z-score table? Okay, so what z-score did you use?
1.6, but I forgot it was repeating.
Oh, okay, so there is more sixes after. Okay, so maybe not 0.9452, so a little bit of pushback. So Destiny, what'd you got, or what'd you get, 0.9515? Okay. If we use calculator, did you use 1.66? If you use 1.67 or the calculator, did you get something close to that?
I got 0.9522.
Did you use 1.67 or a calculator?
I used 1.6.
You used 1.
6.
Just 6?
Yeah, I used the fraction for it. It was 1.6.
So you used the calculator.
Yeah, that's what I'm saying.
Okay, but 0.95 what?
0.9522.
Okay, I'm going to stop and I want to point this out. Are those pretty darn close?
Yeah.
Yes. Could they both be correct?
Yes.
So what's going to matter if I count them correct or not? Your justification. You need to tell me, right? There's multiple answers here that are possible. You need to tell me what value you use on the z-score table. You need to tell me if you use the calculator. Okay? These are the things that, this is why I need you to justify, because there's lots of different options here that are pretty darn close. Those are close, but I need you to tell me how and why you got that. Greater levels of understanding when you explain why, and 2, there's variability in what answers could be correct. Man, words are tough today. Yes, Salita.
How are y'all finishing calculator?
That's a good question. So when we look right here, right, first off we want to base it on the z-score. So did you go to normal CDF? Okay, so what did you put as the lower bound?
1 point. I put both of them in
That?
there. Yeah.
So, well, you don't want to put both of them there because we're looking
I mean,
only
I
at
had the same
Antonio's. Okay, but what's the lower bound? Look at the shaded region. Lower bound is to the left. What is the leftmost value for that shaded region?
21. Oh, -3?
It goes beyond -3.
So -4?
It goes beyond -4.
Negative infinity.
Technically, it's negative infinity. It never quits going, which I told you when it's at negative infinity, I would use -100, or you could leave it as what the calculator has. That literally is just as close as that calculator can get to negative infinity. Won't make a difference.
That's
Okay?
the upper bound or the lower bound?
Well, lower bound is to the left. It's the leftmost bound. There's not a leftmost bound, so it's negative infinity. I would probably just use the -100. Now, what is the upper bound? What is the rightmost value?
5/3.
Say that one more time.
5/3.
Say that one more time.
Oh, I see.
5/3.
5/3 or
1.6
what does this fraction bar mean? 5 divided by 3. The word over does not mean anything in mathematics. Focus on what that operation is. I know you're going to think I'm crazy, but just like Elijah said earlier, I'm starting to get this, Mr. Kinney. I know I'm crazy, but I know a lot about math and I know a lot about language, and it's important that we're careful with our language. Get used to saying 5 divided by 3. Okay, so the upper bound is? There we go, 5 divided by 3. Now remember, we're dealing with z-scores, so the mean is 0 and the standard deviation is 1. That's why I would write my z-scores below every single time.
0.952.
I'd be thinking that like the lower bound has to be the one that's like infinite. You know, like.
That's why you shade it, you draw it out.
So when
The lower bound is just the leftmost part of the shaded region.
So when do I use upper bound? Whatever.
Look, if I have this, does it ever quit going to the right?
No.
So that would be an upper bound of infinity. And it would be a lower bound of like 1.2 or whatever that is.
So when I'm trying to find the left side.
The lower bound is the leftmost part of the shaded region. Remember, it also matters because I could be looking for something like this. And if I say z equals negative 0.2 and z equals 1.1, what's the lower bound of that shaded region?
The left.
The left of negative 0.2. What's the upper bound? 1.1. You need to draw it out to clearly see what is the lower bound of the shaded region. If it doesn't ever stop, it's negative infinity. If it never stops to the right, it's a positive infinity. Does that answer your question, Madison? Any other questions going off that? Salita?
How do you know where it's shaded?
Okay, it's based on the way that the question is worded. So we know that she needs the pizza for the party delivered in 35 minutes or less. So that 35 minutes is going to be my z-score. Boom. In respect to that z-score, do we want less than it or more than it? So it's based on the language of the problem. Okay, it's a good question. Some of our best conversations to date, for sure. Loving some of these active collaboration scores or what they will.
Can we keep going?
So we will finish this up, okay? So what is the probability? So I'm going to just use quotation marks for time. So probability of getting pizza from wood fire.
That's 0.8.
Hold on. Let me finish writing. Within 35 minutes. What is it?
0.8944.
8944?
Yes.
Okay, so I want you to notice, if you are a friend, if you are your friend or talking to your friend, who are you going to recommend based on those probabilities?
Antonio.
You have a better shot. That's a high probability of getting your pizza within 35 minutes. That's a lower probability of getting it within 35 minutes.
So which one?
Exactly. Which
Do-
one tastes better?
It's pizza, bro. Come on.
Yeah. Unless it's Little Caesars, I'm going to eat it. Like, come on now.
Why you like Little Caesars?
I have these things called taste buds, and I make enough money now to afford better pizza.
Oh, what's your favorite pizza place?
In town, probably melon mushroom.
That's
not
Broadway
true. I used to like Broadway pizza, but it's not as good as it used to be.
I like CC
Who said De Palmas? Because that pizza is
De Palmas is
fire.
so
Okay,
good.
that's expensive. I forgot. There's actually and y'all may not have ever been there. There is a pizza place out in Northside, not Big Al's, but Pastor's Kitchen opened another kitchen out in Northside, and they have pizza out there. And guys, you can get their buffalo chicken pizza. It might be one of the best ones I've ever had. Any taco they have, they can make as a pizza. I've had a fajita pizza from there that I thought my taste buds died and went to heaven. It was amazing. Anyways, Pastor's. So there's a Mexican restaurant called Pastor's Kitchen, and they have pizza out in Northside. Yes, ma'am.
Can you keep this on the recording so I can like go back?
Yeah.
Okay,
I'll be there. I'm not editing that video. Anyways, we gotta get back to the math, okay? So please hear me very clearly, right? You have 35 minutes that you need to get that pizza. So who has a better chance of getting you that pizza? Antonio's has a higher probability.
Antonio.
And so here's the thing. Listen, right? Originally we talked about it that wood fire has a lower average, but because of such a high standard deviation, I have a lower chance of getting the pizza on time from them. And that's why probability and statistics matter. We need to know how to calculate these probabilities and how to interpret these probabilities. And so that's where this would come into the real life. I'm going with Antonio's. Antonio's for the win because higher chance of getting pizza or higher probability.
STW.
Yeah. For getting pizza. I gotta do some things to keep y'all awake every now and then.
What is the LTW?
For the win.
Oh my god.
I would say they got the
Okay. Now. Okay. All right. And I will say this: you should write more than that, but sake of time, I want to move on because I do want to point this out. Listen. Okay. Yeah, but that's that 5 minutes left. Yeah, nothing like that, Madison. All right. I want y'all to pause. I want y'all to pay attention to this. What if and this is not something right now, it's just to think about. What if I wanted my pizza within, I don't know, 18 minutes?
Wood fire.
Yeah.
Notice wood fired. The 18-minute mark would be right here. The 18-minute mark for Antonio's is way over here. That's actually going to be just because, actually it's me super low. I don't even know exactly what it is. But that's a less than 1% chance for sure of getting my pizza within 18 minutes from Antonio's. Whereas that might be a 17% chance of getting it from wood fired. So who would you go in that case? Wood fired. And so it matters what you're looking at. Antonio's is not always the best for what we're trying to do. You need to look at those probabilities. It depends on when you need it, exactly. All right, do we have two more? No, just one more activity that we'll look at more tomorrow. We can go ahead and get started. Go ahead and... You must be outside your mind.
You just said we
I said we can get more into it tomorrow. Draw your distributions for activity 4.2. Draw your distributions for 4.2.
For homework?
No, right now. You got 4 minutes.
What page?
That's
Yeah, activity 4.2. Okay, it's like 50 or so. 48, thank you. So draw your curves instead of just sitting there. Draw those curves for activity 4.2. Toby's. Well, are there two different distributions?
I think it's this.
That's how I draw my curve.
That's the homework.
That's what's due tomorrow. Guys, it's on the board. I need you to do those drawings for 4.2 first. Guys, get your drawings done.
That's this page.
Get your drawings done. Okay, Madison, you should take a picture of that as you're walking out of class. Get your drawings done.
That is all. 4 inches. The line is like that.
Shush.
Hold on. No. My curves are down. Knee diameter. 3.6. 1 inch. 8. I never have known that.
Wait, school that? Yeah, that's a valid way to do it.
Hey, no, they don't.
Yeah, so that can work. I just, so here's the issue. The negative 100 doesn't always work, or positive 100 unless you're using the z-score values. And I want you to use using z-scores, so that's why I asked you to just do that. But I mean, that's true, right? If you have a value of 35 for the upper bound and mean of 30 and a standard deviation of 3, that's correct. I would just recommend, and the only thing, I don't want to teach on multiple ways, I just want to focus on one good way that always works. And when you have to go to the table,
How many
you have to calculate the
standard
level.
deviations
So I was just going to focus on Z-score. So it's not wrong what you're doing,
away?
but I'm just going to focus on the Z-score because you have to have that to go to the table. Does that make sense?
I don't know what I just said. I said something. I don't know what it means.
Okay. Go ahead and pause. Before you pack up, I want you to look up here. This is the homework that is due tomorrow. This is the practice associated with lesson 4. If you did not get your talk the talk done that was turned in today, please try to get it to me today before you leave school. Last couple of things, listen. Hey, pause and listen. The test that's on Friday is going to cover all 4 of these lessons, plus the other 2 lessons that were on sampling, right? Random sampling, biased samples, things like that. So you may need to go back and look at those lessons in the book. It's in the very next topic. But I would probably look back over those because you'll notice tomorrow we're going to talk about questions you still have from the unit on top of a few other things. So look through those 6 lessons, figure out what you need to ask questions about. All right? The plan is up there. Pause, actually, that was going to run. Starting, moving forward, I'm going to end the class by having y'all go back to the idea. I'll take one. Sorry. I'll see y'all later. Have a great day. Get your homework done. Do lots of good studying. What am I going to say? Yeah, we're going to go back to that. But yeah, it's actually going to be, we've had a lot of great learning today, but what I want you to always remember is I'm capable of, I always look at things that way. So, that doesn't make things.
I'll get hurt. It's hindering.
Have it up, that don't hurt. If you look at the slides on school, you have it open there.
Thank you.
The slides in school, but talk to me tomorrow if you're there for the test or not.